So now online is not going validate until now. So it will much better video. So let's start the class. So last week, we did active prefixes. Okay. So from today we are going to start the calculating parts.
Okay. So take it and turn to page number 10. So today, before we are going, yeah, you don't have to. Is there anybody without a tube? No, no? You. Okay. So before calculating, we should before we are doing something, before solving questions, we should know rules and regulations to do those type of questions. So there are some important facts that you will have to know. So last week we finished until prefixes. So include when we are handling calculations with prefixes, there are two rules. Okay, the first one is when writing the value of physical quantity with the prefix, the symbol of the prefix should be written in front of the SI symbol. So you should write the prefix in front of the SI unit. That means let's take meters. Meters. Okay, this is meters. So you can't hear. Okay. So this is meter, this is a unit. Okay. So let me take a common, a general prefix. Let's take kilo. So you represent kilo as K, simple K, not capital K, simple K. So kilo is going to represent how much? 10 to the power 3. Okay. So this is a prefix and this is a unit. So we are going to write this K, and after that we are going to write M here. Okay. So we don't write MK. Okay. We should write the prefix in front of the unit. That's why we call that as a prefix. You know prefix and suffix in English grammar. So that's why we call this K as a prefix. That's the first one. And should be in front of the SI symbol without leaving a gap between the two. So you will have misunderstood. Last time I saw some children, they have written, let me take 10 to the power minus 3. Okay, 10 to the power minus 3 meters. Okay, 10 to the power minus 3 meters. So I can write this as 1 into 10 to the power minus 3 meters, right? Ne? So I can use a prefix instead of this. So what I am doing here is I am writing 1 multiplied by instead of 10 to the minus 3 I am going to use milli. Okay, milli, and I am going to write this meter here. We can't leave a space between the prefix and the unit. That's the rule. So I am not leaving a space. I am going to write the M here. Okay. So what's the mistake here? What's the mistake we have done here? Do you write 1 millimeters like this? When I was a small kid, do you write like this 1 multiply into millimeters? No, we don't write this multiply thingy. Okay. When we are converting this to this, you are writing this whole part as milli. Okay. So this is the rule. You should write the prefix in front of the SI unit, and you should not leave a gap between these two. And this multiplication symbol, that's not relevant. Like that's not. You can see that we don't want to write this thing, like because this is a prefix and this multiplication. There's no any calculative part with the prefix. Okay, just it's representing some power of the 10. Okay. No dots or commas should be marked between the prefix and the SI unit. Okay, I have written this in bold letters. I have bolded, this text is bold because this is really important. So, when you are writing kilometers, this is a prefix and meters is an SI unit. We do not keep a space here, there is a small space. We write K and with M I am going to write this, and we can't put a dot or we can't put a comma here. Understand? There should be no spaces, no any symbols between the prefix and the SI unit. Understand? So, there are some examples. Let us take 1 into 10 to the power minus 2, 1 into 10 to the power minus 3 second, one into 10 to the power minus 3 second. So, this is going to be how much? 1, this part is going to be milli. You can refer the table in page number what? Page number 8. Okay, there are the prefixes. Okay. So, instead of 10 to the power minus 3 we can use milli. What is the symbol of milli? Simple M. Most of the prefix symbols are in alphabet, like I mean not Greek alphabet, English alphabetic letters. Okay, English alphabets. Some like one of the prefix have been used to like it has been used Greek alphabet, like that's I think micro, because micro and milli have M in there as their first letter. So, we can't use M to both. So, instead of M we are using this mu, we call this mu. Okay. So, here instead of this I can write simple M, I am not leaving a space, I am not putting a dot or comma, and I am writing S. This is simple S. There is no space. Compared to this space is negligible. Okay, that is how you keep space. Now let us say that you are writing like and school or something, and school or something. So, this is a space and this is not a space. Compare this is not a space. So, with this they are comparing this. If you write this one here, this M here, and keeping this space here and writing S, this is wrong. This is what? Wrong. Okay. So, the next one is 1 into 10 to the power minus 2 meters. So, 1 into 10 to the power minus 2 is, just refer the table and go to page number 8, refer the table. I will ask what is the prefix relevant to this number. So, you are going to tell that number. Okay. 10 to the power minus 2 is going to be centi. So, centi, what is the symbol of centi? Simple C. So, I am going to write 1 simple C meters. Okay. This is how 1 centimeter is made. So, the next one is 1 into 10 to the power 3 meters. Okay. So, 10 to the power 3 is going to be kilo. What is the symbol of it? K. Is it K? No, simple K. You should tell it as simple K. 1 kilo meters. The next one is 1 into 10 to the power 3 gram. 1 into 10 to the power 3 grams. So, I am going to write this as 1 10 to the power 3, 10 to the, that is going to be kilo, and I am going to write grams here. Okay. Okay, this is the first rule. The second rule is, when denoting units with derived quantities, a gap is placed between its basic unit. What is it? This is not basically for prefixes. This is to differentiate prefixes when we are writing derived units. So, milli and meters have the same letter, simple M. Okay. So, when you are writing millimeters, how can you differentiate? Like let us say here, okay, let us take 1 meter second and 1 millimeters. Okay. Now, I am writing, now I am going to write 1 millimeter. I am not leaving a space. This is 1 millimeter. So, I am going to write 1 meter second. Meter is a unit and second is a unit, but that M can also be represented as a milli. So what I'm doing here is I'm writing ms. So whoever the people who knows only the first rule, they will tell this as what, millisecond. But the second rule states that if this is a derived unit, this is a derived unit. I said units are divided into three types: fundamental, supplementary, and derived. More than one fundamental units. Okay, so here we should keep a space. This is not a prefix, so this is wrong. The correct one instead of this is 1 milli, not millimeter, and like this much of space we have to keep here, and we are keeping space and writing s. Now this is not millisecond, this is meter second. Okay, so the next one, for example, they have take meter second. Okay, the logarithm of a quantity or combination of quantities can be considered only if it has no units. Okay, logarithm. Okay, let's take a logarithm 100 to the base 10. This is going to be equal to how much? 2. Okay, 2. But we wrote 10 to the power 2, which is equals to 100 in the logarithm form. Okay, when we are putting something inside logarithm, this rule states that this particular part should not have what? Should not have units. Okay, this should be dimensionless. Okay, this part should not have unit. So this part is going to be this. Okay, understand? That's the thing. So log x, quantity x should not have units. The in page number 10. Okay, and the b part is log xy over z. That's it. Log xy over z. Then which part should not have? Like I'll take this as, let's take this is 10 to the base 10, and let's take this as 7000, and let's take this as to the base 2. Let's take 2. Okay, so which part should not have? This, I mean not this, or this. Which one? It takes it as A, B, and C. Which one should not have a unit? This, or this? I said this 100, then xy over z. Xy over z should not have a unit, but x can have a unit, y can have a unit, z can have separate units, but finally those units should cancel off. Yeah. What? Just give me a second. Okay, either. Let me check. Sometimes there can be like printing errors. So did I write this wrong? Up to the base 10. We write this 2 here. No? this is the power here.
No, that's the result. So that means the product you get. That
Mhm.
is the equal to 2 is the power in this case.
Wait. The result should not have a unit, ne? That's what I say. Mm-hmm. But here they have mentioned quantity x should not have units. Quantity x or y should not have units. Yeah, you are correct. When you are taking powers, we can't take, when you are considering powers, this power cannot have a unit. But what's wrong here? Algorithm of a quantity or combination of quantities can be considered only if it has no units. This is the thing. It can have unit. The thing I just forgot here is it can have unit, but I'm sorry, it can have unit, but when you are using logarithm, you can't write that units inside these brackets. Okay, when you are using it, let's take that. Let's take this 100 meters. 100 meters. Okay, 100 meters. So when we are going to find log of this 100. Okay, so we can't write this as this like this. We can't write this like this. We should, whatever the unit that's here, we can't put it here. Let it be meters or whatever it is. We are not going to put it here. The correct thing here is we should write this as log 100. Okay, I mean to use this. This is a tool. Okay, this is an operation. So when we are using this, we are not writing here. Okay, but it can have a dimension or a unit. So that's what they are saying here. The logarithm of a quantity or combination of quantities can be considered only if it has no units. That is, logarithm can be considered only of a number. Okay, so if we want to use logarithm for a quantity which have unit, so we should not consider that that thing as a part as a unit. Understand? So for that instant, we should forget about units and we should do the calculation, and after that we are going to take the result and put it as what? With the unit. That's what I am saying here. The next part is, as he said, this power, that means this. Okay, this doesn't have a unit. This should not have a unit, because you can't write 10 to the power 2 meters. Ne? You can't write like that. Okay, so then the fourth one states that a certain quantity or combination of quantities can be used as the index of exponential function or of any other quantity or number only if they do not possess a unit. A quantity can be used as a power or an exponential only if they do not possess a unit. Understand? So if you write 10 to the power 6 meters, this is wrong. You can't write like that. This is wrong. This is completely wrong. So you can't put here powers, and here we can tell that this can't have a dimension or a unit. There we can't say, because it can have a dimension, but for that particular instant we are not using that unit to do that calculation. But here this cannot have a unit. Okay. Okay. So for example, they have given e to the power. Can you see red color? Those guys, can you see? Okay, e to the power x, a to the power x, okay, and so on. I'll have 10 to the power x, and all sort of this x can't have a what? This x can't have a unit. Can't have unit. We should have. Okay, can't have a unit. That's simple. Okay, so inside logarithm you can't put the dimension, but it can have a dimension or unit. For that particular instant you don't want to put. And in power parts, this exponential part or this power cannot have a unit, or we can't write a unit, both things. Okay, right. Is there any questions? If you have questions, and if you can't ask them, just write in a sheet and send it to the front table. Okay, I'll take it, I'll collect them. Okay, so I think today the online class is not going parallel to the physical class, because something logged out or something. You all know we should use like a paid account in Zoom to do classes more than 30 minutes, I guess. So that's why it got log out. Something has happened or someone has log out from the laptop. So the online class is not going parallel to this. So but I'm recording the class. Okay. There are new students, right? Who came today? Okay. So at the interval or something, I'll send a small paper. You'll write your name and your number. Okay. So I can add you all to the group. So the next page, rules for using symbols in SI unit. Okay. Rules for using symbols in SI unit. We are going to see the rules when we are using SI unit. This is not relevant to this prefix part. This is relevant to the whole unit part. Unit means not the not this this book. Unit means the units that we use when you are writing physical quantities. Okay. You don't have any doubts, ne? If you have doubts, just clear it. Okay. So the International Committee of CIPM and ISO have provided the following guidelines for the use of SI units. What's CIPM? It's International Committee for Weights and Measures. Okay, weights and measures means for physical quantities. There's a unit, and they are the ones who are standardizing units. Okay, so ISO means it's International Society of something, like it's an international society. So the first basic rule here is the symbol of units named after the scientists have initial. Please refer the tute. Please look into your tutes. Okay, just when you are doing A level, you should have this skill. Okay, this skill, this particular skill. When you are writing something, just write with your head inside this. Okay, I am writing the word writing. Okay, you should have that. And when you are reading, you should go into that particular word and sentence. Read word by word. Okay, you should be very, very specific. Okay, because if there's any word that's not useless, you don't want to take that word. Understand? Especially which stream? Biostream peoples. Okay, right. The symbol of units named after the scientists have initial capital letters. Okay, now let's take, there are several units. There's a full page of units. Okay, several units: meters, kilogram, joules, Pascal, Newton, and also. Now there are let's say in that whole page there are some capital letters also. So that capital letter represents a scientist's name, and the simple letters is some derived unit, but that's not a special derived unit. Okay, special derived units in the sense like basically a scientist's name. So let's take this example, Pascal. Okay, Pascal. So there's a capital as well as simple, but there's a capital. So this is a scientist's name. Okay, so they can ask question like this, like from these options choose the unit which has a scientist name, and they can give me like some whatever the letters X, Y, Z, and let's take A, and here B. Okay, from here which have a scientist name, that capital letter, and what's it? Amperes. Okay, so that's the first rule. Okay, now underline this part in this sentence. The symbol of units you have to underline from here, named after the scientist. Named after the scientists have initial capital letters. What? Initial. You have to if you want to be very specific, underline named after and capital, initial capital. Initial capital. That's enough, because named after scientists, not before scientists, no, after some scientists, they have introduced some letters, and that those are initial capital letters. Why they have mentioned initial capital letters? It's because there are some symbols. Yeah, there are some symbols. It uses two letters. So this, the letter after the last letter is not going to be capital. The initial letter is going to be capital. Okay. For example, amperes, capital A. Meters, simple M. Here they are differentiating it. Okay. So meters we are not writing in capital M, we are writing in simple M. Kelvin it's capital K, therefore Kelvin is a scientist. Kelvin can be a scientist. Seconds is not any scientist name, it's simple S. Watt, it's a name of a scientist, so capital W. Pascal, capital P, therefore there's a scientist, and mole, MOL. Okay, there's no any capital letters in it. Okay, so the next rule here is, we finished the first one. Okay, we finished the first one. The second one here is need to, I didn't put here like a numbered bullet list because there's no any order. Okay, if I put 1, 2, 3, then that's a specific, that's because you want to remember this stuff in specific order, but here you can jumble and remember this. Okay, so the next one is need to keep a small space in between numerical number and symbols. Okay, right? Is it much cooler? No? If there's any problem, just stay. Okay, just hands up and I'll come there. After that you can take. Okay, so you should keep a space between the numerical number and the SI unit, or the SI unit with the prefix. So here I can't write 5 meters. Okay, 5 meters. I can't write. I should keep a space. Okay, understand? That's, you'll understand that partner? Everyone? Boys? That guy? Did you understand? I can see him. Just come here. I should have a view if I can see everybody. Come a little bit here. Okay, fine. Okay. So what I have write something in the brackets. What's it? I write 5m like this. Okay, there's no any space, and you can write this also. Now what they say here is you want to keep a space between the numerical number and the SI unit. So what I'm just using this rule and I'm writing like this. Meter, I kept a space, I write here 5. Is this correct? I use this rule, but this is wrong. What's the next rule? You should write the numerical part or this SI unit after the numerical part. Understand? You should use both those rules. Okay. So the next one here is third one. So second one, I won't write the numbers again. So a physical quantity which has greater than or equal to 1 million. Okay, this is what I said in the last class. Last class I said you use alphabetic letters when you are writing prefixes, but there are some prefixes which have capital letters, and I said I will tell the reason afterwards. So if you go to page number 8, you can see kilo. I said you are going to write it as simple K. This is not simple K. Simple K. This is capital K and this is simple K, I guess. Okay? Okay. So after this kilo, you have what? Do you have simple M for mega? You have capital M. You have capital M. So it's going to be capital M. So what's the reason for this? Because mega is going to represent 10 to the power 6. So 10 to the power 6 means 1 million. So prefixes more than 1 million, what we use? We use capital letters. So do anyone here get some doubts? What's the doubt? You should get confused now. Why? For what other things we use capital letters? What's the next thing that we use capital letters when we are writing units? Scientist's name. Then how can we differentiate this and scientist's name? Let's take from here. Let's take I think we can take T here. They have not given T. Okay, I'm going to write tera Tesla. Okay, Tesla means it's a unit, it's a derived special unit, and Tesla, it's the name of the scientist. I'm going to write T. Okay, I'm going to write Tesla amperes, Tesla meters. Let's take Tesla meters, and I'm going to write terameters. How can you differentiate both? This is terameters, this is Tesla meters. These both have capital letters, but how are I going to differentiate both of these? How? the gap between these. Okay, I said when you are writing prefixes, you are going to write it together, but when you are writing different derived units, you are going to keep a space. So which one should have a space? Tesla or this one? This one. This Tesla. Understand? Okay. If you all don't understand, just go to the previous page, page number 10, and there I have written, when denoting the second point, when denoting units with derived quantity, when you are denoting units with derived quantity, a gap is placed between its basic units. So a gap should be kept between these Tesla, and here you should keep a gap, and meters, and this is different from meters. Understand? Okay. So you should be that much that much accurate. Okay? They are going to ask these type of questions. Okay. So there is mega in the sense 10 to the power 6. You all can see that this is a cockroach here. It's not going to die. It's going to live for like 7 days or something, I guess. Okay. So I have 1M subscribers. That means 1M views means, you'll know, it's M means millions. Okay, so that million is here. So from that you can say I have 1K subscribers means I have 1000, but I have 1M means 1 million. So that's the most common part when you are using the social media stuff now. We don't use like tera, mega, tera, giga. We don't. I don't say like I have 1G subscribers. Have you heard like that? No, you have heard is 1M and 1K. So from that you can remember. So we use both of these, but both of these are going to have one can have simple and one can have capital. Okay. So which one is going to be capital? The biggest one. That means 1 million. So after 1 million you are going to use capital letters. Understand? Okay. So why do we use capital letters when we are writing derived units, special derived units, which the units have come from the scientist's first name, first letter? Why do we use capital letters? We can use simple name. Why? So we should tell that if we compare scientist and a unit, just a unit, the scientist is much a respectable person. Ne? Not like meters. Ne? Newton means that's a Newton, that's a force, and Newton is going to be a scientist. He have done a big stuff to the physics thing. So that's why we put capital letters, and you can remember like this also. We put capital letters due to this stuff, 1 million stuff, and the next one is because scientist, to give a respect to scientists like that, whatever you will remember. So that we are going to put capital letters of scientist derived units. Okay, special names. Fine. So we are going to go to the next part. Still we didn't do like big calculation, no. So the physics class is going to be boring. Okay, you should practice this, especially bio students. Like in biology, it's going to be really no calculations. It's going to be theory from beginning of the class to end of the class. You'll have to be focused. Okay. The next one is symbols do not have plural forms. What's it? Symbols do not have plural forms. I have 1 kilo of tomato and I have another bag 1 kilo of tomato. I don't say that I have 1 kilograms of tomatoes. I can't say that. Why 1 kilogram, 1 kilogram? So I can tell I have 2 kilograms. Why are you going to say I have 1 kilograms? You can't use that S part, plural forms. Understand? Understand? So if this is written, this is not capital, this is simple, kgs. Okay, kgs. kgs. So is this kilograms? What's this? This is kilogram. What? Kilogram? Kilogram? Not per second, second. Okay, per second in sense you should have minus power, you should have this symbol. Okay. Okay. So the next one, no need to keep the space or dot. Yeah. No need to keep the space or dot in between prefix and the unit when writing the prefix with the unit. Understand? We just said this one in the previous page also. Okay. So when we are writing milliamperes, we are not keeping a space. and we are going to write meter here. Okay, this is not milliamperes, this is meter and milliampere. Okay, understand? Do I need to explain it further? No need, I just explained it earlier also. Okay, need to, and you all can't keep dots or commas in between prefix and the numerical and the unit part. Okay, need to be kept dot or space in between two units when writing the compound unit symbols. What's it? So when you are writing something in derived units, you have to keep spaces between each and every unit. It can be Newton, it's a special derived unit. It can be a special derived unit and just a derived unit, you should keep a space. It can be a derived unit and a derived unit, you should keep a space. Okay, that means you have to keep space in between units, not in between prefixes, and you have to keep spaces in between numerical number and the what? Unit. Okay, so if I am going to write 2, have let's say I am going to give a huge space, so you can clearly understand that 2, let's take meters, okay, mega T, and do you understand this? What's this? 2, okay, everyone tell all together, okay, 2, what's that simple M? Milli or meters? Meters, the capital M is going to be mega, okay, mega, T is going to be tera, no, it's going to be Tesla, mega Tesla, simple M is going to be milli, and this S is going to be second, millisecond, and this is going to be Tesla, no, tera, what? Tera grams. Understand? You'll understand? Okay, that's enough. That's one unit, okay? That's not separate units. I wrote one specific unit. Okay, the next part. Okay, now I have to teach division. Division of units is indicating by solidus sign or negative powers. Okay, what division of units is indicating by solidus sign or negative powers? So if it's force, not force, let's take F equal ma, no, it's F equal ma, and let's take M, so M is going to be F divided by A. Understand? Understand? This guy is again going to that side. It's okay, fine. Understand this step? So when I'm writing, don't take this part. I don't have to explain like that. So let's take kilogram per second. So this means you have divided kilogram by second. Okay, you can write this like this, or you can write this kg solidus sign and S. Okay, there are two signs, one is this and one is this side, okay, and those two are not same. You can use this one for division, you should use this one for division to show that there is a division. Okay, you can't write this as kg, this direction is, okay, this represents something else. Okay, understand? Okay. So when you are using solidus sign specifically, so like if we take Sri Lankan A levels, most of the Sri Lankan students, can you come a bit here? If we take Sri Lankan students, they use this this part, like they use most of the students use this, like if we take kilogram per second, they are going to use this power part. But most of the abroad students, they use like this part. Okay, and most of students like 90s kids, sirs, like old sirs, they use this thing. I don't know why, but This should be something new, I think. Okay, but when you are using solidus sign, okay, when you are using solidus sign, what's the solidus sign? It's going to be this or this. It's going to be this name. I first said this. No, no. It's going to be this kilogram per second. Okay. I said it correct, no? Because when I see the book and when I'm writing, I get like it's difficult. Like my right and left flips. No, it doesn't flips, but it's going to like I get confused. Okay. This is correct. Yeah? Okay, okay. The tube is correct. I thought something's wrong in the tube. Okay. So the next one, when you're using solidus, we are not allowed to keep more than one solidus sign. Why? Now let's take kilogram per second per meter. Okay, like this. Okay, we can't write this like this. We can write this. Let's take 1 kilogram. This is 1. Okay, no, this is wrong. Why is this wrong? Because I have to keep a space between this and this. 1 kilogram per second per meter. We can't write this. Okay, if you all have done max and lot of operations, we can't use this because when we put this sign, it's going to flip upwards and downwards, and if you write like this, one can write this again, this thing again like this, kilogram meters over second or something. Okay, just don't take this part. What they are saying here is they are saying that you can't use more than one solidus part. So how are you going to write this when you are using just only solidus? We are going to read. Let's take that I wrote meters before seconds. Let's assume like that. So I'm going to write this 1 kg ms. Okay, this is not millisecond. There's a space. Okay, understand? So yeah, I'm going. This is wrong. This is wrong, and this is the correct one. Okay. So just give me a second. Okay. So then next one is only one prefix can be used for one time. So when you are using prefixes, we are going to use only one prefix. We can't use 3 prefixes. So let's say it's 10 to the power. Let's take 10 to the power what? 10 to the power 14. Okay, 10 to the power 14. 10 to the power minus 14 meters. Okay, so there's no specific 14 minus 14 in that chart. Okay, there is until 1, 2, 3 and multiples of 3. So 14 is not a multiple of 3. So what I'm going to do here is I'm going to write this as separately 1 multiplied by 10 to the power minus 2 and minus 12. I am going to separate this. This is meters. Okay. So let's take this minus 15 and this is going to be minus 3. Okay. So this is going to be what? Nano, right? Nano. So here nano comes and here this is minus 3. So this we can write m, milli. So I can't write this as 1 milli nanometer, m. This is going to be something else. We can't use more than one prefix for a unit. For a unit we can't use one prefix, more than one prefixes. But in a big derived unit, in a whole derived unit, can there be more prefixes? Can't. I guess I haven't seen like that stuff, but according to this rule, only one prefix can be used for a unit. You can, what? I said a whole derived unit. If you take a whole derived unit, there can be kilograms per kilometers. So in a whole derived unit, you have used prefixes twice, but for a unit, you can't use more than one prefixes. Okay, understand? The next one is, in front of decimal number, 0 should be placed. That's not related to, like specifically related to units, but this is for your additional knowledge. Okay, like if you take Apple phones and if you take calculators, basically for fast calculation they use this thing. So if I want to write 0.1, I don't want to click 0 and this point and 1. Just I can put I can touch the decimal key and the 1 key, and that calculator is going to take it as 0.1. Understand? Did you all understand? Okay, that's for the easiness. So some people still write that instead of 0.1 they write 0.1. This is not negative, this is point. Okay, for just easiness. Okay, but when you're writing physical quantities and when you are writing with when you're writing with units, you can't use that decimal part only. You should write a 0 in front of that decimal. That's the last one. Okay. So now we are going to go to the unit conversion part. Okay. So I am not going to do sums now. So tomorrow we have the paper class. I say I am going to start paper classes from this week. So tomorrow you are going to have class from 8 to 12. At this time, in this, I don't think this hall would be free. In Grand we are going to have our paper classes. So in that paper classes only we are going to do sums. Understand? So this is a solid theory class. I do sums. Why do I do sums in between? To explain stuff and to just keep you all without sleeping. You get bored when I just teach theory because I have that experience. Not biology, I am not a biology student. No. When I am learning physics, it's going to be boring when the teacher is going to teach only theory. That's why. Okay. Now we are going to go to the unit conversion part. So you have a value represent with a unit is shown with another unit. Okay. So the first example is, now we are going to show, okay, look your book, page number 12, show 72 kilometers per hour in meters per second. Okay. I have given you dotted lines. You have two sums. First one I am going to do it, and after that if you all can, you can do the second example. So the first example they have said convert 72 kilometers. Now the prefix part and all the stuff is finished. Okay. Now you're going to go calculation part. So convert this to meters per second. Meters per second. Okay, how are you going to convert this? So 1 kilometer is going to be equal to how much? 10 to the power 3 meters. 10 to the power 3 meters. Okay, and 1 hour is going to be equals to, I said h. In where did I say? Go to page number 9. Roman number 4. I said you all consider in the top of the page, Roman number 4, consider h as the symbol for an hour. Okay, understand? This is an international symbol which is used in all languages. In all languages they use h for an hour. So 1 hour is going to be how much? 100 seconds. 60 seconds. Okay. 1 hour is going to be 60 minutes, sorry. And 60, again 60 seconds. So if you multiply 60 by 60, it's going to be 3600. So I'm going to write it in in seconds. Why I am going to write it in seconds? Because they have asked in second. 3600 seconds. Okay. So after that, what I am doing is I am going to write this 72 and this kilometer I am going to write 1000 or 10 to the power 3. I am going to close the bracket, write meters here and put a division here. Why did I put a division? Because this hour is per hour, so that is going to be the denominator. So that hour I am going to write as 3600 and I am going to write this 1600 seconds. So how much is this? It is going to be how much? 20 meters per second. Okay. Just copy this. Okay. Soon, don't take much time. You just have write this thingy and this thingy. I have given this thing. Yeah? That thing. The whole thing you have to write. No, no, just two spaces. Okay. So the next one is just if you all want, you all can try it. Finished. Density of water is 1000 kilogram per meter cube. You have to convert this to grams per cubic centimeters. So what I am going to do is I am going to write 1 kilogram is going to be how many grams? 10 to the power 3 grams. 1 meter is going to be how many centimeters? 100 centimeters. So therefore 1000 kilogram, so I am going to write 10 to the power 3 and put brackets gram here like this, and 1 into 1 meter is equal to 100, so 100 centimeters. Is it correct? What did I do wrong? It's a meter cube. So what I have to do? Okay. So here what I am doing is I am going to cube both of these parts. Okay. So in the next step I am going to cube both this and this. So 1 cube is equals to 1. So this is going to be 1 meter cube, and here let us think this as 10 to the power 2, and this is going to be 10 to the power 3, not 10 to the power 3, 3 and cubic centimeters. Okay. So just be alert, don't sleep. 10 to the power 6 cubic centimeters is going to be 1 meter cube. Okay. So now what I am going to do is, okay, I am going to write 1000 multiplied by 10 to the power 3 grams divided by 1 into 10 to the power 6 centimeter cubed. Okay. After that, this is going to be how much? 10 to the power, here is 3 zeros and here is 3, so it is going to be how many zeros totally? 3 zeros, and here 3 zeros is going to be 6 zeros. So 10 to the power 6 grams divided by, again, 10 to the power 6 cubic centimeters. So the final answer is going to be 1 gram per cubic centimeters. Okay, copy this. HR, is this HNR? Just HN? So 600. My goodness, it's really small, your letters. Okay, let's see. Right here, this is equal to 10 to the power 6 cubic centimeters. You can see this is like 10 to the power 23. So we are going to enter dimensions. Dimension. What's a dimension? Okay, you know 3 dimension, 2 dimension, like that. Okay. The dimension of a physical quantity is the power to which the fundamental unit of length, mass and time are to be raised so that the derived quantity can be completely represented. Okay. So here specifically we are going to use only length, mass and time. Okay. Other fundamental units like we are not going to represent in dimension like current, that's a fundamental unit. So from out of those 7 fundamental units, that's in page number 3. Page number 3, I say you have 7 fundamental units, that's in the table, and I gave you all write that, copy it down. So 7 out of those 7 we are going to use only 3. What's it? Length, mass and time. Highlight it in that page. In the table, page number 3, you have a table. You have length, mass, time, electric current, thermodynamic temperature, amount of substance, 2 minute insert. So highlight length, mass and time. We are going to use length, mass and time only. Is it really agent? Okay. You know it? Okay. So now I'll just take that one voice going. So I'm going to do a really important part. So I'm not going to do that now. After he comes, I'll continue. So in grad, you'll have every classes for science and math stream. Okay. So I'm going to remind again, for biology you have Hemali Kurupu Miss, Hemali Miss. Okay. For maths you have Viraj sir, and for physics me, and for chemistry Asha ma'am. Okay. So they are doing in English medium and they are doing in Sinhala medium as well. So if there's anybody who is just trying to find a class in this Ratnapura or whatever, you'll in anywhere you can tell them to join grant. Okay. Some people like me and Asha ma'am is doing this online also. So from island wide, whatever the students is searching for classes in the science or math stream in English medium, you can recommend this. Okay. Really Asha ma'am has a district first and an island 6th. The East district first and island 6th. Bayan. Okay. So there's nothing, there's no factors to compare that part. Okay, she has the best result. Okay, so she is really good. You all don't understand that. Like there are many rumors going on that she's fast. She's really fast. We don't understand, but you have to practice to that type of fast writing and fast understanding in A levels. Understand? If not, this A level is a competition. This is a competition. Just not an examination, this is as well as competition, because when you all get good ranks, then only you can enter to your dream faculty, dream universities. Understand? You are doing science and you are not going to be a you have a dream, but basically majority of people have the dream to be a doctor. Okay, we are not doing biology, and majority of people have to do engineering when they are choosing the math stream. Understand? So entering engineering faculty and medical faculty is really hard. So for medical faculty, you have to put a high rank in the district. Like let's assume it's 80, almost. I can't remember the medical count, medicine students. Let's take it 70. Okay, I don't know, like average. So you should have a rank more than 70 in the district to go enter a medical faculty. So almost 700 or 800 people write the exam physical science, that means math stream or biology stream, same number of people. 7 out of 700 you have to be the top 70th for medical students. For engineering students, like last in our batch, they took 128 to 130 students for engineering. Okay, so for medicine that count is really a bit lower than engineering, but year to badge and year to year, that's going to differentiate. Okay, just say that average number for medical students. For engineering students, that's going to be 130. Just think 130. If the merit list is increasing, the number of the district quota increases. Okay, if the merit last time merit there were like 35 or something merit students in engineering. Okay, therefore before our batch they took only 100 of students, 100 or 90 students, but our merit students before our batch there were only 20 or 15 merit students, but in our batch there were like 35, almost 35 or 40 merit students. So they have there's an increment like 15. So that 15 is going to be added to the district quota. District quota means there's a district quota, that means they are going to take this much of students to the medical or engineering faculty from this particular district. They are going to make that district quota based on the seats that are available in this whole island's government universities. Okay, you will understand. So you have to, if you want to enter to a university like medical or engineering, so you should go to inside that, you should belong inside that district quota. Okay, so you should have to score a good rank, so that you have to compete with each other. Understand? Everyone, not only you are not going to take a particular rank for English medium or single medium differently. Every English medium, single medium, Tamil medium, all students is going to take the same rank. That means this is a competitive exam between single medium, irrelevant of the medium. You are going to be one batch, 1 year. Like there can be second shy, third shy people also. Then it's a big competition here. Understand? So you will have to go to without classes you can't do A levels. Okay, that's really hard. Not hard, not can't, but like it's 98% impossible. There can be some people who is but have a big brain and you can do without, like that. I haven't seen anybody in my whole life who has done the A levels brightly without by entering a faculty without going to A level classes. So that A level classes is a solid thing. You have to go. Okay, and paper classes and other classes is not that much relevant. But my paper class, I'm not doing paper. I'm doing papers, but initially I'm starting with tutes. I'm doing questions there. Okay, my paper class is not paper class really. I'm going to do questions in that class specifically, and after that I'm going to convert that into a paper class. But basically I'm going to do it as a paper class. Okay. So what I said was there are classes, so you can recommend this teacher and this. Now you'll know, like this is the third week I guess. You'll know about me and you'll know about Asha ma'am. So you can tell this is good or this ma'am is good. If you want, you can come here. Understand? Like whatever we do for marketing, that's not going to get can reach the student's heart. The things that you will tell is going to the recommendation is the best thing to take students. I don't want to take lot of number of students. I just want to tell that students, there's a class here, just come and see. If this is good, stay here. Not good, go. Because there was no any good English medium classes in our batch and after our batch also. Still there are. This is the first batch who has all classes like starting from first to last. But before your batch, there was no any classes starting officially like this in Ratnapura district. Everyone went to online classes for other districts, for single medium classes, like that. Understand? So okay, let's come to the part. So we are going to talk about dimensions. So basically, when you are talking about dimensions, we are going to convert units into dimension, and basically 3 units, fundamental units: mass, length and time. Okay. Okay. So we have, let's take kilogram, meter and second. So this is a mass, this is a length and this is a weight. This is a mass, this is a length and this is a time. This is time. Okay. Basically we are going to convert these sort of the units which have kilogram, meters and second into dimension. Okay. So if we have dimension in the sets, it's relatable to the power. Like dimension, it's power. Like just you have m to the power 2, that means meter squared. Okay, I said meter squared means it's going to be the unit of area, right? So area is a 2-dimensional thing. Understand? So if we take meter cube, that's going to be the volume. So it's a 3-dimensional thing. So with that, I say 3-dimensional, that the part before the dimension means they are describing this power. Okay, so in some units there's not only going to be lengths or not only time or not only kilogram, they are going to be different stuffs. Understand? There's going to be kilogram and meters, kilogram, meters and seconds, kilograms and seconds, and only seconds. Understand? So we have to represent this in this format, but without using meters or the unit part. Okay, that's the just summary of this dimension thingy. Okay, let's go to the second sentence. Dimensions tell us about the nature of physical quantity and do not give any data about magnitudes. Okay, dimensions does not give an idea about the magnitude. Now you have to forget the numerical part here. Let's take 5 Newton. So you are going to forget this thing. Okay, and we are going to use this part and convert this to meters, like mass, length and time. What? Kilogram, meter and second. And again we are going to convert this to m, l and t. Understand? So for mass we are going to use what? For mass we are going to, I'll come by sentence. All physical quantities we found in the units of mechanics and mechanical properties of matter are developed by numerous combination of 3 fundamental quantities. Okay, mechanics. Okay, there's no electronics or there's no wave or things now. So out of the 7, there are 7 fundamental units now. So what are the others? The others are temperature. So basically mechanics, in the sense you don't have temperature in mechanics. Okay, understand? And electric currents, that's not mechanics. Thermodynamic amount of substance, that's not mechanics. Luminous intensity, that's not mechanics. Mechanics in the sense you have basically mass, a length and a time. Okay, we are doing this dimension part to basically the mechanics part in physics. Okay, so fundamental 3 fundamental quantities: length, mass and time. Their dimensions are considered as LMT. So if you go to the alphabetic order, we have L, M, M, N, O, T. So let's go from length. So here now we are going to use L to lengths, not meters or not kilometers, not centimeters, not units. They are what? Units. And meter is the what unit? What unit? SI unit. Okay, not SI units, not units. We are going to use L to represent lengths and mass to represent, sorry, M to represent mass, not kilograms, not grams, not picograms, milligrams. We are going to use capital M. Okay, we are going to convert units into dimensions. I mean, we are going to see the dimensions of the physical quantities. So time, for time we are going to use capital T. This is going to be capital T. This is, again I am telling, this is not related to units, because this is not going to be mega, tera and what? Something L. This is not mega, tera something. We are finished from the unit part. We are entering the dimensional part. Like you are entering to a new universe or something. Just think like that. Okay? Yes, we are going to see these units in a different point of view. Okay? Understand? Okay. So this can be, length can be given by meters. Length can be given by meters, kilometers, picometers and all the stuff. Okay. Mass can be given by kilograms, grams, milligrams, pounds. Pound, I don't know the pounds and all the stuff. Here you can use inches and all the stuff. Inches, foot, feet, all the things we use to measure length. Okay. For mass, you can use mass, kilogram, milligram, pound, so whatever. We are going to use only this letter to represent masses and this letter to represent length, and this letter we can't measure the time in another unit. We have only seconds and hours also. So we whatever it be, hours, minutes or seconds or milliseconds, we are going to use this T. Okay, from now. So how does physical quantity connect with its fundamental quantities? How physical quantities connect with their fundamental quantities, their basic quantities. So, physical quantity in the sense it can be a force, so whatever, derived, supplementary, everything. How are they connected? They are connected by the fundamental units. Okay. So, how they are connected is they are connected by the dimensions. Okay, from the dimensions, specifically mass, length and time. So, there are some dotted lines you will have to complete. Yeah, it can be explained by referring a symbolic method. Okay, to explain how the physical quantities are connected with its fundamental quantity, we use what? Dimensions, symbolically, to represent how physical quantities are connected with the fundamental quantities. Let us take a physical quantity, force. Every time that is the easiest example. Force, that is a physical quantity. How force is connected with the fundamental units? What are the fundamental units? Inside it, kilogram meters per square second. You have to like we are using that kilogram meters per square second every time. So, you can memorize it, or you get memorized to it. Okay, you yeah. So, force is going to be equals to force is going to be measured by Newton. So, Newton means kilogram meters per square second. So, in that physical quantity, what are the fundamental quantities in it? Mass, length and time. To explain a physical quantity symbolically, how they are connected to fundamental quantities, we use dimensions. Okay, that's why we use dimensions. Okay, so there are some points. We are going to write something like some sort of rules. Okay, take your pens and start write. There are three bullets. So, the first bullet is going to be, when we are presenting a particular physical quantity, start write. What's the matter? When we are presenting a particular physical quantity, with its dimension, comma, when we are presenting a particular physical quantity with its dimension, comma, usually it has been presented it has to be presented inside square brackets. It has to be presented inside square brackets. So, what does that mean? So, when you are going to represent physical quantities by their dimensions, you have to represent them inside square brackets. Let us say I am going to represent force in its dimensional form. Force, okay, I am write this force dimension. So, when I am writing the dimension of this force, I have to put it inside the square brackets. So, this can be written as kilogram, meters and seconds. Okay. So, inside force you have what? You have mass kilogram, length meters and you have time seconds. So, kilogram is in kilogram formats, and kilogram, what is the power of kilogram? Do that kilogram have a power in force? Do that kilogram have a power in force? So, I am going to write here for your reference. Force is equal, can you see green color? You can see. So I am going to represent a kilogram meters per square second. Okay. So kilogram, do it have a power? Yes or no? Yes. What's that power? That's 1. So the power of this mass dimension is going to be 1. Okay. Okay. But these are what? These are, we took mass, length and time from which table? From the table in the page numbers 8, I think 8, no, page number whatever the page, where the fundamental units I described about fundamental units. So these 3 symbols belongs to fundamental units. So this force we have to convert into its fundamental units. We have to see the fundamental thingy inside those physical quantities. Okay, pay your attention here, because if you take the first unit, calculations that come inside this unit is from dimension part. Okay, this is, if you miss the dimension part, you don't have the unit 1 knowledge, the theory knowledge. Okay, there's practical knowledge. Okay, in practical knowledge you have to think there are stuffs, but in theory knowledge, if you miss this part, you are going to be in a real mess. Okay, so if you take length here, it's in meters. Okay, pay attention, everyone, pay attention. So meters, what's the power of meters? 1. So meters represent, sorry, length is represented by meters. So here, what's the power of length? If we take the dimensions, it's going to be 1. Okay, this is the power of length, 1. So if we take time, the dimension time here, it's raised to the power minus 2. Okay, if we take the dimension time here, it's raised to the power minus 2. So when we write it in the dimensional form, we are going to put that power here, minus 2. Understand? Okay, this is what we are, this is how we are going to convert physical quantity into its dimensional form. Now this is very easy to it's very easy to recognize that inside a force there is 1 mass, 1 length and 2 times to its negative power. Understand? It's really easy and it's very clear. So that's why dimensions are used to what? To explain physical quantities symbolically, how it connects with its fundamental quantities. Understand? That's the question, how does physical quantities connect with its fundamental physical quantity? It can be explained by using this symbolic form, and this is why we use dimensions. Okay, so you wrote the first sentence, no? The second sentence is mass, comma, length and time, mass, comma, length and time are the fundamental physical quantities, are the fundamental physical quantities, ne? Yeah, which belongs to Newtonian mechanics. Newtonian mechanics. Newton is derived from the word Newton. Newtonian. So there are different types of mechanics. You can go and search about them. Okay. Basically, for A-level syllabus, we are going to use Newtonian mechanics, the mechanics that is taught by Newton. Okay, and still not finished. Full stop. Continue that second point, second bullet. Their dimensions can be written as capital M to the power 1, capital M to the power 1. Don't write capital M to the power 1, just this thing. Okay, there are some students. this. The dimensions can be written as m to the power 1 comma capital and capital L to the power 1. You're out of space. Just put the arrow here and continue there. Everybody's out of space. Yeah, basically I just kept only. You missed something. Belongs to Newtonian mechanics. Their dimensions can be written, just put, if there's no space, I have given 3 bullets. I have given you 3 bullets. So if you out of space, don't write in the third bullet, just put an arrow, and if you have space here, continue that sentence. Okay, don't write in the third one, then it's going to be messy. So if you have written, then cut this bullet point, and when I'm giving the third bullet point, just write it somewhere else. Okay. So however, you should remember there are 3 bullet points basically. So after Newtonian mechanics, full stop, the dimensions can be written as m to the power 1, L to the power 1 and t to the power 1, full stop. M to the power 1, L to the power 1, t to the power 1. Okay. So when you are studying, this is just a tip. Okay, when you are studying, just be isolated. Isolated means just be separately, or I am not telling to just stay away. When you are studying, you should study. When you are learning, you should learn. When you are eating, you should eat. When you are watching movies, you should do that particular work. You should focus on that work. That's a discipline. Understand? Discipline is I'm not the one to make the disciplines. Means the motivation which you are going to keep permanently. Motivation means it's just a boost, just a temporary boost. If you have that boost inside for a longer period, that's going to be a discipline. So every time you have to be motivated. You have to motivate yourself again and again and to be disciplined. So when I am teaching, okay, you should have to focus me, okay, and I'll give you breaks. Then you can enjoy that break. And when I'm giving to write, when I give something to write, you have to write. So if you focus the teacher when he's teaching, so it's going to be really easy to study. It's really easy. The easiest path to study without going and like turning all the pages and just highlighting. This is the easiest way to look at the teacher, to focus on the teacher when he's teaching, when he or she is teaching. Okay. So the next bullet, we are studying only Newton mechanics dimensions. Okay. We are studying only Newtonian mechanics. The word Newtonian is going to be in capital. That means N is going to be in capital because that's a name of a scientist. Newtonian mechanics dimension. We are studying only Newtonian mechanics dimension. Okay. Usually it has been presented inside the square bracket. It has to be. Okay. This is right in present perfect or something. Comma. Usually it has to be presented inside the square brackets. We are studying Newtonian mechanics dimension. Usually it has to be, or it should be presented inside square bracket. Usually it has to be presented inside the square bracket. So if you missed the 3 bullets, I will just read just like from top to bottom, just correct them. When we are presenting a particular physical quantity with its dimension, usually it has to be presented inside the square brackets. Okay. So the next point, mass, length and time are the fundamental physical quantities which belongs to Newtonian mechanics. Their dimensions can be written as m to the power 1, L to the power 1 and T to the power 1. Third one, we are studying only Newtonian mechanics, dimension, comma, after dimension you should put a comma. So, usually it has not so okay, I just said that word. We are studying only Newtonian mechanics dimension, comma, usually it has to be presented inside square brackets because there are mechanics what introduced by other scientists also, like just go and search about that. Not only Newtonian mechanics, there are some mechanics. Like Einstein uses a separate type of mechanics. Okay. So after that, just I have given a small example. Mass, to explain these sentences, mass you are going to write inside this bracket and you are going to write equals to capital M, or you can write it as mass inside capital, so square brackets is equals to inside a square bracket also. You can write it inside a square bracket, whatever. But you just don't want to waste time by putting square brackets, no? You can use this. This is more simple. So the meaning of the above m to the power 1, the meaning of the above m to the power 1, I have given it, ne? Yeah. M to the 1 is the dimension of the mass would be 1. The sentence is a bit grammatically wrong. The meaning of the above m to the power 1 is that the dimension of the mass should be, oh, it would be, okay, just ignore it. The meaning of the above m to the power 1, here the power of this m is 1. So the meaning of it is the dimension of m is 1. Okay, the dimension of this m is going to be, mass is going to be 1. If it's area, that m is going to be raised to the power 2. So the dimension of this m is 2. Understand? Like you have separate dimensions m, l and t, and inside they also can be raised to another power. Like it's a bit complex, so you will understand when you are doing questions. Hence, index of the m is its dimension. Therefore, the index of this m, what's there? Index of the m is its dimension. Okay, you have 3 dimensions now in Newtonian mechanics, MLT, and the index of them, let's take x, y, z. No, I'll write it big. In Newtonian mechanics, you have mass, length, and time. 3 dimensions, and the power here x, y, z is going to be their own dimension. Okay, because you see, if you have m to the power 2, L to the power 1 and T to the power 1, you can also write this as m into, like I am expanding this into L into T. Just you do not write multiplications between this, I am just to explain this. Okay, here there is 2 m's. So there are how many dimensions? Like 4 dimensions, and the dimension of mass have been, there are 2 dimensions of mass. So if you take a particular dimension which is different, that dimension has 2 dimensions itself. Understand? Understand? Okay. So the next one is dimension and units are several physical quantities. Again, dimensions and units of several physical quantities. Just wait a minute, wait, just don't write. Okay, dimension and units of several physical quantities of, cut that are, yes, dimensions and dimension and units are several physical quantities. This should be of several physical quantities. Okay, the first thing I have given as an example is area. Area. So area, I'm going to find the dimension of area. Oh, it's 10 o'clock, ne? So okay, just have your break and come. You'll have minutes or 15 minutes. 15 minutes break. Okay, just have 15 minutes break and come. After that we can complete that part.
First class I didn't record because I recorded it, there was a small mistake. So I revised the first class into second. I have the second recording. You haven't joined it. Okay. I have uploaded it to YouTube and I have shared the link to the other group members. So if you want, I'll put it again.
3 boys. Yeah. You wrote the number, no? I'll add to the group, and after that I'll send, just remind me to send the first recording. I'll send it privately. Who is Evin? Evin Kaul? Evin? You? I didn't come. You're from Lyceum? Video from Lyceum. Can you just write your name and your number, WhatsApp number? Then I can. How many are from Lyceum? 6. Aloysius? 2. You? Gampaha? Dharmapala? You? Yeah, purple color. You. Huh? Hollywood Center. Biostream Island First is, no, district first is from Hollywood, ne? Biostream district first is from Hollywood Central, ne? This time. Okay. Okay, you wrote it. Just give me. So you also just put me a message after I'm adding you to the group privately. Then I can send the recording. If you want, you can watch. So I record. This is the third class, ne? So I recorded the first class, but there was a small mistake with the mic and the video. So I just deleted that, and I just revised the first class again in the second class. So like the note is not there. I didn't read the note of the first class. The note you can just get from your friend, one of your friends. Okay. Now let's come to the topic. So dimension and units of several physical quantities, page number 30. Now you see area. We are going to find the dimension of area. So how do you find an area? You're going to multiply length into breadth. So both of them are lengths. You're going to measure them in meters. So I'm not going to use, okay, I'll write it as length into width, okay, width, breadth, both are same, width inside the bracket. I didn't take them outside the bracket because I just expanded this inside the bracket. So why did I put these box brackets? Because I'm going to find the dimension of this physical quantity. So this is going to be equal to so here this length is in L, we measure that in meters, and this width is also a length, ne? That's also a length, and we measure it by meters. So we are going to multiply L and L together. So the final result is that's going to be what? We are not writing 2 L's here, we are going to write it in a single format. So we are going to write it in powers. So what's the dimension of length here? It's 2, and there's only one type of dimension, L. Okay, so I have given this and this. You have to write this and complete this. Okay, so area's dimension is L squared. What's the unit of area in standard units? Tell me. In standard can meter squared. So if you want, you can write that also, meter squared. Meter squared. I just write it nearby. Okay. After that we have volume. So volume in the sense you have, what's the formula of volume? Length into breadth into height. You have another dimension. Okay. You go from second dimension to the third dimension. So this is volume. volume. Inside square brackets we are going to find the dimension. So, it is going to be length into width into height, and that is equals to, so we are measuring length by meters, width by meters and height by meter. So, it is going to be in meter cubed, the unit, standard unit. Let's take this as SI unit, SI unit, this column. So, this is going to be in, this is going to be in L to the power 3. So, what is the dimension of L here? 3, it is in the third dimension, okay, right. Now, let us go somewhat complex, a bit complex. So, we are going to find the dimension of acceleration. Acceleration. So, what is acceleration? What is the definition of acceleration in O levels? Rate of change of velocity. Then you are dividing velocity by time. So, what is the definition for velocity? Rate of change of time, rate of change of displacement, not distance, displacement. Okay. So, now these are the things that is running in my mind. So, acceleration is rate of change of velocity. I divide velocity by time, and velocity is displacement divided by time. So, finally, from this, if I substitute V here, E divided by T and T, so acceleration is going to be distance divided by time squared. Okay. So, that means you are going to have one length and two what time. Okay. Okay. So, the formula of acceleration, this is acceleration. Okay. This means TION. So, I am going to find acceleration by dividing velocity by time, rate of change of velocity. So, what is the dimension of velocity? So, you have to find the dimension of velocity. So, let us look into the how velocity is made. So, if we take velocity and we are going to find the dimension of velocity. So, what is the dimension of velocity? How are we going to calculate velocity? Displacement divided by time. So, I am going to write this as displacement is measured by, displacement is a length, okay, by meters. So, I am going to put here L, and I am going to divide this by what? Time. So, time is capital T. So, now I am going to do is, I am going to take, this is a denominator. So, if I write it in the denominator form, you can write this as T, and now I am taking this T upwards. I am going to take this T upwards. L T to the power, what is the power of T now? Minus 1, because here is 1, if it comes to the numerator it is going to be minus 1. So, the dimension of velocity is LT minus 1, okay, LT to the power minus 1, okay. So, I am going to use this here. Okay, right. And what I am going to write here is I am going to put LT minus 1, okay, and divide this by, I am going to divide this by what? Time. The dimension of time is t. So what happened here is this t goes to up, LT minus 1 and another t minus 1, and here if multiplication between two same term, then we are going to add it up, LT minus 1 minus 1. So that is going to be what? LT minus 2 minus 2. This is the answer. So what you will have to write here is, this step is not relevant. This is, you don't write these steps, you are not kids now, and this step you don't want to write it here, you can write it at once. This is, I wrote this to explain you. Did you understand, okay, how this calculation goes? Okay, so I am going to erase this part, and take this part to part here. And this yellow color stuffs, this is what you want to write here in this book, and here this thing, you have a small space here, you have dotted lines here, you have some space here, you have dotted lines here, and you have some space. So what you have to do is, in acceleration, the things that have written in white color, write in these blanks. This yellow color stuffs you can write here in small font. When you're writing it in pencil, just write it a bit smaller, because there are some other stuff, so you can use this space to that stuff also. Hey, any problem? Where are you seeing gel pen in your walls also? No, I just asked, if you want you can write. No. You finished writing? Yes, that's easy. Force, momentum. This is minus 2, right? Should be. These tables you are not sitting indicates that there is a separation. You have 1 gang, 2 gang, 3 gangs. Don't be like that, okay? Just make a lot of friends, then it's going to be easy. Okay. You? Okay. Take hand. This one. You are from? Both of you. Oh, all of you. Both of you. Just write the full form. Don't write like that. If you are going to write, you are going to confuse again. Like you have used W here, no? Then you will think that that's a symbol. Okay, just write in small letters EIGHT. Wait, not wait, ne, with. You're from school? Lyceum. You? Hilbert. Where? Avisal. You? Ah, that was subject. Is there any notice about your O-level results? Not still. You wrote O-levels on which month? Ah, this year, February. You don't have, to the -3. Very good, -3. Yeah, then that's a dot. I didn't tell you about in dots. No. Then it's going to be something else. Cut this whole part. Rewrite it LQ. Understand? Mass into acceleration, mass into velocity, force into displacement. Okay. Okay. You understand? I'll check everyone's book. Yes, that this girl. I don't know her name. Head prefect. She's not doing bio stream, or she changed the stream. Don't know. Just contact. Just ask why she's not coming. Okay. So the next one is you can try if you can. So I'm going to erase this part. So the next one is force, momentum and work. Force, momentum and work. So force. So what's the formula for force? How are you going to find the force? You're going to find F is equals to ma. So m is mass divided by, not divided by, mass into acceleration. ma. So mass is going to be in, what's the dimension of mass? Capital M, kilograms, capital M. So acceleration is in, here we have found the acceleration. So it's going to be LT minus 2. So now you have a new dimension, MLT to the power minus 2. What's the dimension of mass here? 1. Dimension of length, L. Dimension of T, minus 2. Okay, there are 3 types of dimension, and there's 1m, 1l and minus 2 t's. Okay, so copy this and try to do the momentum and work. Ajit, the light off panel. Yeah, light off. Here. Is it dark? These two dark. Is it dark here? Because in the recording, these reflections just bother this stuff. You can't see it. Other lights also, but these are two. Just it's making very hard to write. What can I do? We can decrease the reflective surface. We can rough this screen. Okay, you're trying them, ne? Let me check. UN force into displacement. Multiplied by force. Force into perpendicular distance. If you write perpendicular distance, then this perpendicular stuff is going to be relative to this force. Right? If the force is in this direction, the distance is going to be in this direction. Okay? What's that? Force into perpendicular distance. How do you find momentum? Oral knowledge, mass into velocity. So you write that part here, mass into velocity part here, write the dimensions and final output. So how are you going to calculate work? What's work? Work done. Displacement into, force into displacement, not perpendicular displacement. Okay, perpendicular in the sense we are finding respective to the force. Okay, perpendicular distance respective to, if the force is in this direction horizontally, if we take this is x axis, so the force is going to be in the y axis perpendicular. Okay, so what is force into perpendicular distance? Moment, M-O-M-O-N-E, moment, moment, M-O-M-E-N-T. So continue this part also if you have much time. So acceleration is going to be kilogram. Write it in standard form, standard unit. Kilogram meters per square second. And sorry, this is going to be force. This is going to be meter second. Sorry. Kilogram meters per square second. Likewise, continue this. It should be in the standard unit. Wrote it. Standard unit part. Write it here. Write it here. Everyone, do that. That's good. This is 0. You are writing indexes in small letters. So when you cut it, there's going to be something else. Like someone can tell m to the power 0 or something. It's better if you cut this and rewrite it. Okay. Yeah, this also force into displacement. Same name. velocity, ne? This is velocity. This is like u. No, that's a dot. No, no, it's okay. But don't write it. We should write like this, pointy one. Force into what? No, not perpendicular distance here. That's L. Let's double cut this. Cut it again in the next direction. L squared t minus 2. This is not perpendicular distance. Where do you write? Force into perpendicular displacement is what? Moment. That's not force. I said last time also, both moment and work or energy has the same dimension. Okay, how are you going to calculate moment? You'll have moment in all else, ne? You'll have it's going to be force into perpendicular distance. So this is going to be Newton and this is going to be in meters, Newton meters. And if you see work done, how are you going to calculate work done? It's going to be in force into distance. Okay, this is not perpendicular distance. That's not, they haven't specifically mentioned parallel perpendicular distance, but it should be in the same direction. So force is going to be Newton and distance is going to be meters. Then it's going to be again Newton meters. You can write this in joules, but you can never write this in joules. This is not joules. Okay, this is not in joules. You will study it in when you are going to these subjects, because these two are vectors. Okay, force and distance. This is also force and distance. When you multiply two vectors, it's going to be a scalar. There are two types of multiplication vectors. It's vector multiplication and scalar multiplication of vectors. Okay, so this is scalar multiplication of vectors. Here this is being multiplied in the method vector multiplication. So when it's a big stuff. Okay, it's not in the syllabus also, but if you can understand what vector multiplication represents, then you will understand what a moment is. Okay, moment is a bit like, it's a super mind-blowing thingy. Okay, I didn't check them. So work is going to be force into displacement. Force into distance. You wrote me. Displacement. Logo කරන්න බලන්න. මේ size. Your biomax. Bio. It's going to be really hard. Like, it's really hard to read, Nick. You're from Hollywood Center. You did orders in English medium. You have to maintain a good handwriting. Handwriting is good. I mean, yeah, that's nice, but the thing is, it's really small. So I'm going to confuse this. I thought this is a multiplication because you represent multiplication like a dot. Like we can represent multiplication as a dot. Okay, that's why. So just look into that. That your fault is that you have to look into your letters. Okay. This is not good to write it in brackets here, because that can mean that you are multiplying these two stuff. Okay. So So it's better write it here or something. Yeah, after the equal sign you can do it. This is like tally mark. Write the units also. Did you write the units? No, ne? Just try to write the units also. It's much better. I usually didn't write. Ne? You continue to do that. I checked you, no? Joules. Okay. Let's go to the dimensionless physical quantities. So there are quantities without dimensions. There are three types of physical quantities: fundamental, supplementary and derived. So I said derived units, and there's another part called as numerical values. Numerical values. Okay, what fundamental, supplementary and derived units. Apart from this you have numerical values, that means without no units. Okay, so if we take, I'll put it in a double line mark, if we take units, fundamental physical quantities has a unit. Okay, supplementary has a unit. Okay, radian or steradian, you can remember it. Okay, so what's this derived units? Derived physical quantities, force, those stuff, special derived units and not special derived units. So they also had what units. Okay, so numerical values, do they have units? No, they cancel. They had, but they cancel off due to their we are dividing two stuffs, we are taking the ratio, so they don't have units. Now we are going to dimensions. Dimension. From this you can understand what's the difference between fundamental and supplementary. Okay, why fundamental and supplementary is different to each other. So fundamental physical quantities has a dimension, that is mass, length and time. Okay, mass has a dimension, that is m, capital M, length has, that's L, time it's T. Okay, that's how the dimensions are made from the fundamental. If you go to supplementary, physical quantities, they have a unit, but the thing here is they don't have a dimension. Okay, I said supplementary unit, basically there are two types of supplementary unit: radians and steradians. Radians and steradians. Sterad. So both of these are a sort of angles. So this is an angle, this is a 2D angle, this is a 3D angle. Okay, so we measure them in rad and sterad. So if we take a 2D angle, how do you measure it? By what? Degrees, or we can measure it by rad also. Like, does the degree have a meters inside it, a mass inside it, a time inside it? No. But if you take that's degrees. Okay, but if you take radians, that's another type of measurement of angles, like meters and inches. Meters we can measure lengths, inches also we can measure lengths, but here rad is like sort of same. Degrees we can measure angles, and rad also we can measure angles, but rad is defined from a type of rad is defined as a ratio of to its own radius. Okay, it's a ratio. Rad is a ratio. Okay, like this. Let's take, there's a circle and we want to measure this angle in rad. What we do here is we take this radius and let's take that is r, and we measure this length from here to here, to here. Okay, I think it's called as arc. Not sector, no, arc. So we are going to measure this length, and what's the meaning of rad here is the ratio between these two. Let's take this as x. Okay, so we are going to measure rad, the magnitude of this angle, that's theta, and we are going to find that result in rad. So rad is going to be x divided by theta. Okay, so x is going to be in meters, theta is going to be in meters. That's a length. So those two cancels off, and those two of them cancel off and you get the final output in what? X over theta, this is x over theta rad, this is a unit. Okay, so these fundamental units cancelled off, but this is a unit basically, but there is no fundamental unit, then there is something, this is something without a fundamental unit. Okay, and this is a ratio. So this is the difference between fundamental and supplementary unit. So they have a unit but they don't have what? A dimension. Okay, dimension is made up from fundamental physical units. So I am going to, if you want you can, I didn't give this before, if you want you can write this like in that steradian radian part. Just give me a minute. What happened? My goodness. What is this? Whatever. You can see this dimension here. You can see this also. Then that's all. Okay. So this doesn't have a dimension. So do derived units have a dimension? That's what we are finding. Force is a derived unit. So it has a dimension, and that's mLT to the power minus 2, mLT minus 2. So do numerical values have dimension? No. So that's why we are going to separately identify physical quantities without what? Without dimensions. Okay. Now you can write there relative density. There are like 5 points you have to write. Relative density. What's relative density? It's a ratio between two densities. You take the density of one thing respective to another density. The next one is refractive index. Refractive index is also a unitless and a dimensionless quantity, physical quantity. The next one is coefficient of friction. These are stuff that I taught you in the last week and before last week. My goodness. Okay. The third one is plane angle. Plane angle means the angle in one plane, in a 2D plane. If you join two dimensions, then only it's going to be a plane. If not, it's just a single straight line. Everybody come, you'll participate in Arham ma'am's class, ne? You'll come to Arham ma'am's class? You? Okay. So the fifth one is solid angle, plane angle and solid angle. To make a solid, you should have 3 dimensions. So solid angle and plane angles, they have units but no dimensions. So in there's a part from this curly bracket, there's a dotted line right there. Both have unit both have a unit, but they have no dimension, both have unit but they have no dimension. Okay, that's all. So determination, the next topic is determination of the different dimensional physical quantities. What have I typed this? Determination of dimensions of various physical quantities. Quantities. Okay. So now we are going to use the writing book. Everybody brought a writing book, name? No. You brought writing books? A4 sheets A4 sheets or A4. Oh, okay. So there are some exercises. Find the dimension for below physical quantities. So here we found the dimension of area, volume, acceleration and force. Now you have to find density, angular momentum, torque, velocity gradient, expression. Start to do from 5 to 8. Okay. Let's see. You have to do 5, 6, 7, 8. 5, 6, 7, 8 in page number 14. So if you don't have a writing book, let me give you some A4 sheets. You have? Okay, you have found it. Do you have anything to write? We are going to try. Take from someone else. Wait, I'll see. I just forgot to mention, like the paper class is going to start tomorrow. So what you'll have to bring is, I'll give the tudes, but you'll have to bring your notebook. So there are some like MCQs are there, so you can do it in the tude itself, but some essay questions you have to do it in a separate book. So you can use that books to do like small sums from this theory tude. So I'll take a bit of time to explain the class plan. So for a month you have 8 classes. 8 classes. One is theory class and 4 classes are theory classes and 4 classes are tude classes. Both is going to be 4 hours. So for a week you are going to come 8 hours. You should come to the paper class also. So you have 8 classes and totally I am going to take you 6,000, okay, for this class. So you will have to participate and there's a small plan that one of my instructor gave me like this. So if you will participate like continuously for 8 classes, you are going to get 1 class free, okay. This I didn't implement this plan. So from this I put this plan not to cut classes. If you will like you came 6 classes, let's tell you came 7 classes, you missed 1 class, then you are not going to get that offer. Understand? So like if you come continuously for how many months? 4 months, you're going to get the next month free, okay. So I'm going to do a thing like that, but I still didn't implement it. I have a plan. Let's see, after 1 month finishes, I'm going to see your attendance, how you are coming and not. And if there's a continuous, like a lot of people are coming continuously, I'm going to let. If everyone is coming like one day, not coming the next day, then there's no use of putting this. So if I see if only one people come continuously and others doesn't come, that's going to be a profit to me, because he will get a free class, others will pay me. Understand? Okay. Okay, start to. It still didn't get A4 sheet. Okay, you didn't bring about. Take this evidence. Just do it here and attach this to a notebook. I will have. Anybody without notebooks? Girls bring regularly notebooks. Yeah. Okay. So the first one is density. Fifth one is density. That's going to be mass divided by volume. So mass is going to be in M, capital M, volume is going to be in L cube. So the final result is going to be M L to the power minus 3. Understand? So how many of you get that one correct? Okay. What have I forgotten here? I have forgotten something to mention. What's it? Density, and I have found the dimension here. I haven't found any density here, but the result is in dimension, but this is in a physical quantity. So I have to mention this inside a what? Square bracket. And this one also we should mention it inside a square bracket. If you haven't put square brackets here, your answer is totally wrong. You all don't get answer for the final result also. Okay. Lot of you had mentioned that, ne? Here. Change in velocity. Yeah, change in velocity. Yeah, v1 minus v2. Moment of inertia. You don't know that. Don't do the seventh one. Moment of inertia. Angular acceleration. Don't do the seventh one still. I'll explain it when I'm doing the tube class. Do the eighth one. You can do it. You did the seventh one.
I tried doing it.
Do you know what moment of inertia is?
I've heard the term inertia before. So inertia is like the work which an object possesses, right, sir? I don't know.
Angular acceleration.
It's a type of acceleration, so that one must have been correct.
No.
That's not correct. Okay, then it's a different unit, right, sir? The simple acceleration is
Angular acceleration. So it's going to be in rads per square second. So rad doesn't have a unit. Understand? So there's no length dimension there.
Oh wait, so these are when the term
You have the angular moment there also. No? So wait, I have to do that. Moment of inertia again. You will need formulas to do these questions. So I did the fifth one. Let me do the sixth and seventh and so on. So a lot of tried that, but I don't understand how they did. How do you know moment of inertia's unit? If you don't know stuff, just ask me. So questions related to what's the second one? Sixth one, angular moment. Force, density, angular moment, moment, angular moment. Okay, I'll do like this. These are some questions from the tube. I don't know how he burrowed into this question, this tube. Okay, it's fine. Let's do angular moment. Okay, what's angular moment? Angular moment. This is related to the third unit. Yeah. So angular, just you all know moment. What's moment? Force into perpendicular distance. So angular moment is going to be moment of inertia into its angular velocity. Okay, angular velocity. So moment of inertia in the sense, what's inertia? I'm just doing, I'm going to just introduce you all to the third lesson, a bit of angular moment, angular motion. Okay, what's inertia? I want the definition, exact definition in O levels. It starts with the word reluctance or resistance. Reluctance to move an object that is stationary or to stop a moving object. Okay, resistance from that object to start motion and resistance of a moving object which is moving in a uniform velocity to stop it. It's hard to stop a train, a moving train, and it's hard to pull a train. That's because of its, if we compare a train with a small little, let's take this bottle. Okay, let's say the bottle. So compared to this bottle and the train, which is much harder to start the motion, and if it's going like this, to stop the motion, train or this bottle? The train. So what's difference between this train and the bottle? One is volume, okay. Other than volume, what's the difference? The mass, okay, the mass. You can make a plastic train also, ne? Of the same size. You have a metal train and you have a plastic train, which is easier to stop when it's moving. The plastic train. To move the objects, to start the motion, that's also the train. Since the volume is equal, what's the difference in these two objects? It's the mass. So to start the resistance to start a motion or to stop a motion is known as inertia. So in linear motion, what's linear motion? In one direction. If a motion is going in one direction, it's known as linear motion. In linear motion, the inertia is its mass itself. Okay, but if you take angular motion, let me introduce to angular motion. Angular motion is in the sense you are going to have a pivot point, you have a fixed point, and you are going to be in a separate distance, and you are going to move around that point. A circular motion, angular motion or a circular motion. Okay, so however, inertia is based on mass, and if you take angular motion, there's another thing adding up. If you take same type of two balls and tie it up to a rope and fix it to 2 points, okay, one has a smaller radius and another one has a bigger radius. So if we start to move these two balls, it's hard to stop the ball with a big which has a longer radius. So in angular motion, what's inertia? The resistance to stop something or to start moving. Okay, so if we compare these two, the one with the long rope is harder to stop. So the length, means the radius, ne? If it's a circular motion, the length of the rope is going to be the radius. So the radius is also going to be included in the inertia of that moving object circularly. So that inertia is known as moment of inertia. Okay, that is angular moment. Okay, understand? So that is angular moment, and to find that's moment of inertia. What's this? Moment of inertia. That's moment of inertia. So angular moment means it's a moment. Okay, so like let's take this moment of inertia is going to be a type of mass. How you are calculating this is a mass into radius squared. Okay, it depends of 2 like square to the power of radius. Okay, square of radius. I'll explain it further in that lesson, but the moment of inertia, that is proportional to mass and proportional to radius squared. Okay, and this moment of inertia differentiates from one object to another object. Okay, we considered a rope and a ball. This is pivoted here. Okay, so this one's inertia is mr squared. But if we consider a log or a stick, whatever, a wooden stick, and if we pivot here and if we rotate this, so the mass is going to be in every place. So here we are taking something known as average mass. It's not called average mass, and for then what happens here is there's going to be a constant here. These are something in the angular motion. Okay, I'm just introducing to that lesson. So there's no specific equation for angular momentum. That's what angular momentum, ne? Have I mentioned it in the book? Sorry, moment of inertia. So angular is moment of inertia. Sorry, moment of inertia. There's an O here. Moment of inertia. Since this moment of inertia depends on the type of the object, the equation is going to change. If it's a ball, it's going to change. I gave 2 papers. Okay. Understand? So from object to object, the moment of inertia is going to change. So I'm not going to write a formula here. Instead, I'm going to use units. Irrelevant of the constant here, the unit is not going to change. Okay, from object to object, I said there's a, like if you take a ball, it's mr squared. If you take a stick or something, it's going to be 3 over 2 mr squared, 1 over 2 mr squared. There's just a constant is going to add up to the equation. So that constant doesn't have what? Doesn't have a unit. Understand? So the mr squared unit is going to be the unit of moment of inertia. Okay, so instead of writing the formula, I am going to use the unit because unit is same to all sort of moment of inertias. Okay, so I am going to use this mr squared moment of inertia. Not mr squared, sorry, kilogram, mass is going to be in kilogram, r squared is going to be in meters, so I am going to write meter square. Okay, and this angular velocity, here is angular velocity. Everyone wrote this angular velocity as ml t minus 1 meters per second ne? Everyone wrote it like that ne? But this is not velocity, this is angular velocity. Okay, in angular velocity there is no distance or displacement. You can't measure a distance, it's going in a circular motion ne? You don't have a distance or displacement. You have the distance from this point to this point, that's only the thing. But if you take angular velocity, this angular velocity is measured in radians per second. What? They are going to measure the magnitude, the angle per second. If it's rotating in a uniform speed, uniform angular velocity, that means it's going to rotate 360 degrees in some amount of time. Understand? So we can find if we take like to rotate 360 degrees, if it takes 5 seconds, so we can divide 360 by 5. I means 5, number 5, yeah, not pi, number 5. So we can take degrees per second. That's how you'll understand in O levels. But in A levels, we are going to use radians instead of what? Instead of degrees. So 360 is represented by 2 pi radians. So if it takes 5 seconds to move from here to here, we are going to divide 2 pi by 5 and we will get the angular velocity. So what we do here is, I'll just this is I'm writing in another color because I'll use this. So it's going to be 2 pi radians over 5 seconds. Okay, so from here, what's the unit? Rad per second. Ne? Rad per second. Understand? Understand? Everybody understand? So what I'm going to do here is, so I didn't erase this. So I'm going to write here rad per second. Okay. Now I gave you all a clue. You can go to the next step. Okay. The next part you can try. Angular acceleration means rad per square second. After that, what you will have? Moment of inertia kg m square. initial momentum, acceleration, angular velocity, change in velocity and displacement. This isn't it? Yeah, you did it.
Yeah, we did. Certainly we did.
Change in velocity.
Change in velocity is acceleration.
Rate of change of velocity is acceleration, but here it's change in velocity. So velocity, one final velocity minus initial velocity. So it's going to be a velocity. Okay. So do the angular next part. What's it? Angular. After angular momentum, you have torque. Okay. Torque is going to be moment of inertia into angular acceleration. So it's going to be multiplied into. So it's going to be. So force into distance is going to be kg s minus 2. You are going to have another distance. So this is going to be moment of inertia is going to be kg m square accelerate. So do the torque part in your home. Just for homework, do it. Try it. If you can, you try it here. So I'm not going to check it now because these questions are there exactly in the tube. Okay, and you have the next 9th one, and you have those are a bit longer. It's a bit longer question. So I am going to do the 9th one. No, I'm not going to do the 9th one. I'm going to do the 10th question. You'll have to try the 9th one at your home today itself at your home when you get a free time, because we are going to do these type of question in the tomorrow's class. So I'm not sure about the tomorrow's class because I'll confirm it in the group. Okay. So let's go to the 10th question. So here we are not going to put this inside close brackets. Okay. Okay, we are not going to put units also inside close brackets. So if you'll have put this thing inside close brackets, just remove those close brackets. Okay, so let's go to the 10th one. Poisson's equation can be shown as below. It shows the rate of viscous liquid flow inside a tube. Okay, this is what I said. This is the equation from the 10th unit, properties of matter. It's about viscosity in liquids. Okay, so this is a huge question, huge formula, right? 5 a to the power 4 P over 8 eta L. So Q is going to be liquid volume flows at 1 second. Volume means capacity. Okay, volume in the sense you are going to put V cube, volume per second. So liquid volume flows at 1 second means rate of change of volume. Okay, that's Q. So A is the radius of the tube. If you take, let's consider this liquid flows inside from a tube, inside a tube. So what here is the radius of this tube is going to be R. So A. P means pressure difference. So there's going to be some pressure here and some pressure here. Let's take it P1, P2. So pressure difference in the sense difference between these two pressures, P2 minus P1 or P1 minus P2. So that's going to be a pressure difference. So if you take a velocity difference V1 minus V2 is going to be meters per second minus meters per second. Let's take it as 2 and this as 1. So the final answer is going to be 1 meters per second. So if this is a plus or minus here, the final answer will get the exact dimension of these two, unit of these two. Understand? There's a rule. I'll go to that rule when we come to the principle of identical dimensions. So that's why difference between pressure is going to be delta P, pressure is going to, I'm using advanced physics, pressure difference in the sense the final unit of pressure difference is going to be what? Pascal itself. Okay, understand? That's what I tried to explain. So after that we have the length of L is going to, N is going to be viscosity of fluids, L is going to be length of the tube, and find the dimension of viscosity of the liquid. So we have to find the dimension of eta. So this exact question is in tube. So let's do this question. Let's do the principles. We have only 30 minutes, I guess. Yeah, 11:37. So okay, there are some theory parts after this question. Now we are going to do a question. So let me do it quickly. Q is equals to, the formula is going to be Q is equals to phi a to the power 4 over this. So phi a to the power 4 P over eta L, 8NL. I just remembered this equation like this, phi 8, so I remember it as phi AN, and this is like N of and PL plate, phi 10 plate, like from that sentence I just remembered this equation, phi 10 plate. You will understand, it's a bit weird, ne? So you can use like that stuff to remember equations because this is a huge equation, I can't remember this. Okay, now what I am going to do is, I want to find the dimension of this thingy. That's the viscosity of liquid. So I am going to subject this N. So what I am doing is, this is a denominator. That means from this part we are going to divide this. This is in a denominator. So what I am going to do is, since this is a division to this, if I want to cancel this, I have to multiply this by again an eta. Okay, so I can't do this to only to the right hand side, I should do this to the left hand side. I am going to write it eta here. Okay, so this 2 gets cancelled off. So now eta is in this side, but we have to subject this eta. That means we have to get off of this q. So to get off of this q, I am going to divide this q. So I can do it, I can't do it only to the left hand side, I am going to do it to the right hand side also, q. I don't write 2 multiplication symbols, I don't write, just 1 is enough. Let's take this as a ratio. We can, if you want, you can do that also. We can extend this and put a multiplication sign here. Understand? Is there any doubts? No. So this is going to get cancelled off. So we subjected this eta in one step. Okay, is it complex? If I did it in one step, is it complex? A bit complex, ne? Okay, I'll do it again. So I'll do it step by step. This is how we do in one step. So I'll do that in step by step. So again the equation is going to be Q equals to okay. So what I'm going to do is, I'm going to take this eta here, Q eta phi a to the power 4 P capital P over 8L. Okay. So in the next, I'm going to take this phi a to the power 4 P over 8QL. Understood? Understood? This is step by step form. Okay. That's simpler, no? Than that, but you have to practice to that. From one step you have to substitute, then go to the final answer. Okay, so it is eta. This is not n. I just remembered this as an n because we can't put an eta here. A eta, it's really hard to remember this. So the formula is going to be like this. So what they say is that telling to find the dimension of this. You are going to find the dimension of this viscosity of liquid, viscosity of the liquid. So what I am going to do here is I am going to make it smaller. I am going to put a boundary. Sorry. And I am going to find the dimension of this eta. Okay. Is this correct? Is this correct? I am going to find the dimension of eta. So if I write like this, can I find the dimension? No. This is, I am going to find the whole magnitude and the dimension from this. To find only the dimension, I have to put this inside square brackets. So this is going to be equal to this whole part. What? Phi a to the power 4 p 8 kiv L. Okay, understood? Okay, I have balanced this equation left hand side and right hand side. What I am going to do here is I am going to find the dimension of each and every separate parts. Okay, so I am going to write phi inside. So I can do like this. To make stuffs easier, I can check phi. Phi is a constant. So this it's a unitless constant. Okay, so it doesn't have a unit, means it doesn't have a dimension. So we don't want to find the dimension of this phi. And 8 is also constant, it doesn't have a unit or dimension. So we don't want to find these things dimension. So I am going to find the dimension of this a to the power 4. I can write like this because the symbol represents the dimension only. But if I am doing the formula, I can't just write this and pressure, and in the denominator I am going to write Q and by length. Understood? Where's the 5 and 8? Where did it go? It went. We don't want to find that because they don't have a unit or dimension. Since they don't have a unit or dimension, we are not going to put 0 here. Okay, we are not going to put 0 here. They don't have dimension, so we neglected that part. If you put 0 here, this and this, the whole thing is going to be 0. Understand? So we don't put 0. We don't want to put 0 because we can neglect them. We are going to neglect them. Okay. After this, sorry. After this, I can't, I can, this is the maximum size. So now I am going to write them in, I will use this color. I am going to write this in dimension part. So A means what? What's A? Radius of the tube. Go to the book. Radius of the tube. So radius, we measure radius by what? Measure radius by meters. The standard unit is meters. So it's going to be a length. So the dimension of radius is L. Okay, the dimension of radius is L, but it is raised to the power 4. So there is going to be 4 radiuses. So we are going to put 4 here. Okay, understand? After that, I am going to put a multiplication symbol. And here P, we don't want to put multiplication. You can just write that P, the dimension of P, but I will put a multiplication for your understanding. So P, what's P? Pressure. So we have to find the dimension of pressure also. For now, have you find the dimension of pressure until now? No, you haven't find. So I'll give it here. I'll give it like here. Pressure is going to be force divided by what? Meter squared. Ne? So it's going to be force m1 s minus 2. Okay, understand? I just did this in one step. Understand? Okay, so I'm going to write directly here. I'm going to write kg here, g, not kg, sorry. I'm going to write this as m L minus t to the power minus 2, and I'm going to erase this part. Okay, just think I have given this data. Okay. Wait, doesn't this move? I have decreased the white color. Okay. So this pressure I am going to put M L minus T minus 2. Okay, understand? Yeah. Okay, okay. So after this, did you understand till this? Everyone, boys, do you understand? Is it complex? Not complex, ne? You? Okay, you? That one, like that. Did you understand this? Okay, you all? Everyone understood? You? Yeah. So Q, what is Q? Volume flows at 1 second. That means rate of change of volume per 1 second, per second. So it's going to be what? It's going to be volume is going to be, sorry, not volume, it's volume rate. Volume rate is going to be what? Meter cubed per second. So meter cube in the sense L to the power 3. So L to the power 3 per 1 second. So T to the power minus 1. Understand? Okay. So I am going to write this one here, L to the power 3, T to the power minus 1. I chose another different color. It's okay, fine. There's no time. And now I am going to multiply this by L. L is what? L is the length of the tube. So I am going to put here, it's measured in meters, so it's in L. Okay. After that, cut and polish, you will get the answer. You all know to cut and paste, ne? So I'll take a different color here, and it's going to be this. You can cut, there's 3 L's, 1 L to this 4 L. This one to one of this, so there's going to be 1. So the final one is going to be what? It's going to be, is that green? It's a yellow, ne? No, it's white. Whatever the color. So this is going to be in. You can see this, ne? So this is going to be M L minus 1 T minus 1. That's not good. You should write everything. Just copy paste this thing. I have given a space, but that's the problem. Okay. For now, what you all should do is write this in your writing book. Okay, the whole thing soon. Okay, write this in your writing book, and just only this part in the what in your tute. I have given space for question number 10 in page number 16. பெப்பர்
11 வளர்க்கிழமை வளர்க்கிழமை கிளாஸ் இருக்குது. 18 லீவ்.
18 லீவ். தென்
நியூ இயர் கிழமை
12
இதெல்லாம் லீவ் ஓகே. இது சரி
இது லீவு.
இது
இது லீவு. நான் சண்டேயும் கிளாஸஸ் வைக்கிறேன். இப்போ
எல்லாம் லீவ் அந்த கிழமை
19
19 அதை மட்டும் நான் கொஞ்சம் கேட்டு சொல்கிறேன். அப்போ உங்களுக்கு நெக்ஸ்ட் வீக் உங்களுக்கு சொல்லிக்கிறேன்.
ஓகே. ஸோ 11th நெக்ஸ்ட் வீக் இருக்கிற நெக்ஸ்ட் வீக் பேப்பர் கிளாஸ் இல்லை. அடுத்த வீக் தியரி கிளாஸ் இல்லை, பேப்பர் கிளாஸ் இருக்குது. ஓகே. ஸோ இந்த பேப்பர் கிளாஸ் இந்த தியரி கிளாஸு பேப்பர் கிளாஸ் இதாக்கினா ஓகே.
நான் கொஞ்சம் அதையும் கேட்டு பார்த்துட்டு சொல்கிறேன்.
அதை கொஞ்சம் 19 பேப்பர் கிளாஸ்.
வர கிழமை சொல்லிக்கலாம்.
Okay, for today the class is over. So tomorrow you have the, I'll confirm the tute class because my exam in semester is going on. I'll tell it, okay, if the class is tomorrow, you should come, okay. Just be alert in the group.